4 by 32 is the formula, correct? I mean 2. If you substitute or is 2, still or, then 2. Let's substitute pi times or. How much is or? In this case, first case is 100, right? 50 is the diameter, right? 100 mm diameter. Radius will be divided by 2, 50 mm radius. Okay. I substitute this 50 mm divided by 1000 will be 0.5, right? 0.5. 0.5. 0.5 power 4, correct? Power 4 divided by 4. What is the answer? Give me the answer. And then similarly, I write the value for hollow. Let's find out the value for hollow. J hollow will be a differing in, because the diameter, this is a solid member, right? It's a solid member of diameter, radius 50 mm, right? But in the next case, it is, the first case, it is a big one. Oh, it's solid. I don't know the drawing tools. All are following? Are you doing in your notebook? Just want to double check. Is it audible to you?
Yes.
Yes, miss.
You're following, right? Are you working out? Can you switch on your camera? And want to see whether you're working. Similar questions I will ask in the test next time, I mean next week. So you need to work out. Are you doing it? All of you switch on your camera. Good, all are here. What happened to Nabil? How many times I excused for attendance? Nabil, why he's not joining? Busy gentleman. All of you switch on your camera and work out the question. Very simple one, direct. You just work along with me. We are going to have another few minutes. In 5 minutes, the question will be answered. Then we move on to other questions. All of you ready? Only 2 people switch on. Konkanala, Kosa, Muntasir, Nawal, Ongzen, Rehman, Saraf. Please. Muntasir is there. Okay. I continue. You can hear, right? It's audible, right? I'm sorry, I just noticed the background noise. I will go to setting and next time I will minimize it or arrest it. You can follow, right?
Yes.
Okay. I will continue. Okay, continue with that. I share again. So the total is 100. Okay. So I substitute the radius this one. In our second case is a hollow member. I think I use this to insert a very nice option. I should have the ring. Oh God, I have. So hollow ring is also there. I substitute here. Okay. Let's draw a substitute. This is circular hollow ring. Diameter, inner diameter. How much is removed? The material of the question. The material of 75 mm is removed. The rest is 25 only. Okay. The rest is 25 only. Am I right? Is the question correct? 75 mm drawn out. 100 is original. 75 mm hole is made out. The rest will be 25. Come on. So the total is 100. Original one. The same one. Keep the same size. Otherwise, if you're confused. The same case, it was given. Material of a material of 75 mm is removed. Inside 75 mm removed means both sides you deduct, right? Carefully do this value. I put it here. Side calculation here. Draw. Okay. And 75 mm is removed means 100 totally. 100 minus 75 will be 25. But this 25 is left, right? Only 25 is left. But for both sides, divided by 2, right? Divided by 2. How much is divided by 2? 12.5 on both sides. The thickness will be, right? Am I correct? Are you following? You left with 25 only. The 25 you need to divide on both sides. Diameter, right? Yeah, diameter. So you left with 25 all through the sides, because n to n is 100, right? You remove 75. You remove 75. You left with 25, which should be shared by both sides, right? Should be shared by both sides. As I'm doing here, it will be right. Sorry, 12.5. Okay. Okay. This is the remaining. So on both sides it will be 12.5. 12.5. Am I right? Is the value correct? Right. Let me mark here. 12.5 and 12.5. So accordingly, it's all diameter, correct? I'm doing correct. It's again diameter, but better if we write down the all value. We need the all value only, right? We need the all value. I hope you understand this part. Now let me draw together radius value. Radius, that is also important for this. Maybe I can write right here somewhere. One moment. Okay. We need the radius, right? What is the net radius? Radius will be subtraction between the net radius, right? The radius is we only need this portion. We only need this portion. We only don't need this portion. The stress is distributed to this size of the member, because it is hollow here, right? There is no stress distribution and the material is not there. The material is there for this section only. Just now we found that this is 12.5. Okay, let's find out the distance. Let's find out the distance from the center of these points. Okay, from the center, I'll draw the diagram. From here, we have 1 and 2, right? You know the last one. The last one is, this is at 50 mm already. To find out, can you read it clearly? Is it small? Okay, make it bigger. 50 mm. Okay, from end to end is 50 mm. End to end is 50 mm. I left with so touchy. Let me switch off the touchpad. I will do that later. Sometimes I need this. So my material is here. So I need to know what is this distance, the remaining distance, right? Center to this distance. Totally 50. Cut 25 will be another 25. right? 50 minus, we already found that this gap is 12.5, isn't it? And this is 50. Can you subtract now? 50 minus 12.5 will be, come on, tell me, how much is it? 37.5. Are you clear with this calculation? Because, okay, I just put order. Okay, this is hollow, right? This is hollow. So I need to find out the net diameter acting at this point, available at this point. We are not a very good artist. That's why nowadays they teach art also in the kindergarten. Now time there's no art. It's optional. Okay. 12.5. I now got the net diameter which is to be subtracted. Are you clear with this small calculation? Where we left with 37 point from center to this. All right. Okay. So I will have this value. This, if I do that one, so I left with this value as 37.5 mm. 37.5 mm. Are you clear? If you have question, you can ask me at the end of the class or immediately, so that and you also cross-check my calculations then and there. That is most important. I think my space is not enough. Are you clear? Let's move. Very simple one. Similar questions will be asked in your exams, tests, and so on. Be careful. Unit is mm. Wherever you can have space, please write down. Right below. Oh, my mm is bad. Okay, let's move on. Pi r power 4. My r is like this. Okay, my r is like this. Pi r power 4. We need to find out the shear stress, polar moment of inertia. The main r is 0.05 minus individually. R power 4 can. R power 4, I have to, or if you want, I can write the formula first. This will be capital diameter, outer diameter. I write like this: pi outer minus pi inner. Radius can, radius. R I put. R outer minus R inner. If you subtract, you will get this one. Okay, R outer minus R inner. Then you will have this value. That is what we have done here. So R outer minus R inner, we did it. Now we got this value, power 4. I substitute pi. The explanation is over here and on the side. Our R will be, capital R will be 0.054 minus 0.0375. 375. Maybe I know this bit. Write down pi 0.05 power 4 minus 0.0375 power 4. Stop me if it is not clear at any time. Come on. Find out this answer. This will be your tau hollow or T hollow. J hollow. All in meter per 4. All in meter per 4. Because I did resolve that already into meter, so it will be meter per 4. Get me this answer. We can substitute conveniently in our calculations. Okay. We found the polar moments. Now we are moving on to finding out our required torsion. Recall our torsion formula. We can then find easily. We know that, I write it like this. We know that shear stress is equal to, use the shear stress formula. use the shear stress formula. We know that shear stress is equal to torque times rho over J, right? Now allowable, I repeat, for the allowable should be equal to allowable. Now you are given it allowable should be equal to allowable in this case. Okay, what is that value? Better write down 100 megapascals, correct? 100 megapascals. Let me substitute. I need torque, so I separate it out. Torque of the solid, we do one by one. Whether you are asked for two things, right? I make it a solid, torque of solid. I use the same thing, right? Yeah, all solid. Yeah, torque of solid. Solid material will be torque of solid SO1 is equal to tau allowable, tau allowable tau allowable. Just rearrange the equation and write down. You can skip doing. Don't wait for me. If you know, you start doing. I request all of you to work along with me, okay? So that you know what is wrong and right. You get good practice of doing things. It's not that you just listen only, okay? You can, because you have enough time while I do editing of this thing. You have plenty of time to write down and follow. Okay, allowable. I just rearrange it in this equation. My T solid will be T allowable. I remove, otherwise you get confused. T allowable, the J will go up. Okay, J will go up. This J will go up. So I end up with rho, gentleman rho at the bottom. Correct? Rho will come down if I rearrange it. Can we now find out the value? Get me the value, please. Let's substitute. T allowable is 100 megapascal. I change it to 10 power 6. Better, you keep it simple units so that uniform. J we already found. You substitute here and then divided by how much is the value of this rho. It's for solid, right? The solid diameter will be 100, right? And 50. So distance from the center of the things will be 0.05. Get me the answer for solid torque. That is first answer, and then second answer will be I give you the answer. Then you need to complete. You do some work, otherwise it will become spoon-fed. You will not have a practice at all. Okay, kilonewton meter. We got a first answer already. Come on, let's work out for the similar way. We can work out for tau hollow, torque hollow. Okay. So first one you found already, T solid. The same formula I'm using. I use the same formula, and then T hollow will be. Repeat the same equation. T hollow will be equal to tau allowable, same for the same allowable stress. J polar moment. This polar moment solid, because it's varying here because of the material. You need to follow the similar respective values, and distance also varying. Let it be here. Substitute. Allowable already there, 100 megapascals, right? 100 megapascals, and then divided by into J already we found out, right? They just substitute the polar moment of inertia here. And the distance is, in this case, is difference. You need to take the difference between these two. Am I right? How much is the value for this one? 0.0375. Right? A hollow distance, 0.0375. This one, the diameter. Distance from the center. Can you see my arrow here? Distance, no. The distance from the center to the point of interest or the hollow material. Right? It will be 375. So substitute 375. You will get your answer for moment of inertia. You need to substitute here. You end up with T for hollow, and that too in what is the unit torsion? Since I substitute in newtons, it will be Newton meter. Did I write the unit here? Newton meter already. You can change to kilonewton meter later on. You will get it in Newton meter. Change to kilonewton meter. Okay. Get me this answer. With this, the torque value for the two shafts have been found out. Finally, you're asked to find the shear stress. Okay, shear stress distributions, right? Shear stress distribution in the section. Okay, let's draw the shear stress distribution diagram. You follow the same way that we did it. Section A will be, for the section B, it will be looking like this. Okay, I give you time. Can you draw it? Wait for you. Otherwise, I do it. By this time, you should be able to do it. Now wait for another 2 minutes. Hi, hello everybody. Are you there? Can you draw the stress distribution diagram for hollow and solid? Where's your camera on? Not on at all. Can you all switch on your camera? Draw the stress diagram. If anyone is completed, you can raise your hand. I will ask you to show on the screen. Stress distribution diagram for solid and hollow member given there. Just now we analyzed and we plotted already all the, we calculated all the values. Can you now draw the cross section of the shaft and plot the stress distribution? Very simple. If anyone interested, you can share screen and show your drawing. I will give permission. Make it sportive. You can make mistake, no problem. Don't worry. Be bold and you can show it. You can make mistake now. Who is raised hand? Gentleman. Who is this? Nobody raised hand yet. Okay. Anybody knows about Ahmad Nabil? How many times I excuse now? If anyone knows, please let him contact me. I will also try to contact him. Last time I couldn't. I do one if you want. So far we are working on very simple question and answer. Direct, simple in the sense direct one, where the moments are given to you. Torsional moments are given to you. Very simple one. Please practice. In tests I follow like this, but when you go to exam, lengthy questions will be asked. So you have to get ready for this. If not this week, next week, you should, after test, you should get ready for doing lengthy questions. I mean to say force will be given. You need to generate your moment and then find out your stress or whatever the section asks. Okay, anyone ready? All of you switch on your camera. It's recording, you see. You have to show your participation, your duty to show your participation in the class. Then only we can check your how much you learn, what is your requirement. If finished, you can share your slide. Just focus your camera onto it, or just show the paper like this in your camera. Madam, I done like this. I appreciate you. Don't make me to force you to do things. You have to come voluntarily, right? That is how we learn. If it is going not responsive, there is no response getting, I have to charge you by attendance. If no response, no attendance, like that. It is as though you switch on and left already. Okay, please be careful. You have to participate in the class. That's important. Okay. Done. Another 1 minute. Otherwise, I give you the drawing. You so many messages. Okay. Come on, you take down this. If you cannot, I will explain. I share this first. Any volunteer to show the sketch? If not, don't worry. I understand your situation. You still need more classes. Okay. Can you understand this? This is the answer for your question. Can you hear me, all of you?
Yes.
Okay. This is for the solid, and this one is for your hollow member. Solid is of 100 mm thickness. We just now saw. Stress distribution perpendicular. The distribution actually perpendicular to the circle. This is only showing the cross section of the shaft. Imagine yourself that it is being twisted about the support, isn't it? It's twisted like this. Okay, the cross section, from the cross section, I mean, if you look at the cross section, the distribution is like this. At the center is 0. Imagine it is on the surface. It is on the surface. So it is going, reaching from the inner material, travel towards the boundary of the cylinder or the shaft. You will have maximum at the surface, right? You know the reason why it is, am I right? Because it is sheared. Shearing stress is resistance. Resistance offered by the material is more here. As you go inner, it becomes 0. No more layer to provide resistance. But when you start from here, there are many start from here is 0. Got many materials, layers, right? And then towards the end, it will be maximum. If you want, next time I'll bring the animations to understand even better. For now, let me explain for the hollow section. Imagine perpendicular to the circle. Imagine perpendicular circle projected to the perpendicular to the circle or perpendicular to the slide. If you check this material, since there is no material, there is no distribution inside. But starting from here, or the radius 0.0, right? This is 0.0375. From 0.375, the material starts again some value, right? There is some value. It is not 0. There is some value, and then go increasing to a maximum at the wall. Okay. Let's see the dotted line. It is hidden. If the material is there, you have to draw. If not, it will be like this. The distribution is like this. All of you draw in your paper. You need to do such things in your exam if asked, okay? For plotting shear stress across the member. Shear stress distribution. It is a graphical representation of the value. You have to think that The plot showing graphical representation of the value, and the line sketch, the circle shows the position. 0 moving, you take it as an element, a section. It's only the section. We are plotting for a section of the shaft. If we take section of the shaft from the center, the value will keep increasing to maximum at the surface. I repeat once again, the plot is only the value, not on the diagram, on the member, right? We have taken a thin member, a film. I even have had here. I wanted to use the disk, floppy disk, my CD disk. I don't have. It's a thin element, okay? The diagram shows only the values. Okay. Hope you understand. We move on to the next question. Have you written this? Draw this? Shall we move on? Okay, let me solve the next question for you. Any question? Are you there? No question, right? Okay.
Yes.
So far we solve for given the target torsional moment. Now we are going to solve for given the force, calculate the moment, and then move on to calculating your stresses. Do you want to work out some questions now? Before I move on to the lengthy question for practice, do you want or not? Anybody, any objection? Shall we start with because if I give homework, you are not doing it. Can you do the next question? I give you 10 minutes time like last time, then I work out the other question. Yeah? You can do it, or you want to do later? Up to you. I have given 3 questions. Yes.
Where you put the homework? Because I don't know
The
where you put.
same in the same file. The tutorial sheets are uploaded onto CN last class. If you go down, you are seeing the slides, right? If you go down, all this shaded one, this one I will work out because different types of questions I'm solving. And then towards again, you see the shaded ones. These are all your homework. See, practice one. Last class we did this, isn't it? All you have you done this one, or you want the workout for this? Practice one is already done in the last class. I gave 10 minutes. You people solved it. I don't know how many solve unless you speak out. If you find difficult, always you approach me. Okay, don't keep quiet. We are doing. See, next week I'm going to start with another chapter. Don't pile up your doubts. Finish it off then and then. And I have left with 1 and 2 and 3. 3 I will do it later because it's kilowatt and all, which is more mechanical oriented. I will see whether we can cover in this module or not. Otherwise, it's replaced with our building question. But we left with one more question on shafts, circular shafts, which is there in your syllabus. Okay. Do you want to solve this question? It is in the same tutorial sheet Word file that was uploaded in CN. It is there. You go to page number 8, you can find this. Maybe less than that because I am working now. Can you all solve this one now? Try the similar way we just now we did it. Only thing, okay, I have to give you another difference. The module is stress analysis and design, right? The meaning of stress analysis is it depends on how and what you are determining. If you are determining shear stress, forces, moments, drawings, right? Do drawings of shear force, bending one diagram, torque, stress diagram, all these things are called as analysis. The design comes, the word design comes because in examination or in any of the applications, either you will be asked to find out variables like forces, moments, shear stress. These are all called analysis. If it is asked to find out the diameter, cross section, size, depth, width, radius, these are all called design. When you size the member for your design for your structural member, it is called design. Except the sizing, right? Dimensions, sizing, cross section, depth, width, radius, all other solutions that you are getting are classified under analysis of the member. You are analyzing the member for a stress, force, moment, torque, allowable stress, maximum stress, ultimate stress, and so on. Clear? Right. If you didn't answer my question, somebody answer in the chat box. Yes, you want to do, right? You want to work out now? All of you switch on your camera and solve the second question. Start putting hands on the paper and do it. Please start doing it. Second question is displayed to you. Can you all start doing it? I want to see. I will suddenly, otherwise I will open a separate room for each one. I will go through each room and check. Is that okay?
We can try.
Yes, already. Practice 2, can you all start doing it? We'll have with another 5 minutes. Start doing it. I want to see whether you can proceed or not. Similar way, the same type I am giving. Just reproduction with some changes, applying your knowledge and understanding of this chapter. All of you switch on your camera. I'm going to take screenshot today. Let me see how many of you are doing. Quick, please. It is like mathematics. Unless practice, you will not learn. Don't worry about covering many topics. You should cover at least clearly and in a better understanding way. Then you can do rest of them, right? All of you switch on your camera. Only one person switched on. Adel Gamal. Okay. Draw the diagram. Write the given data. If you want, I post the video in the group. Wait, I post the video. Just for your use. I post the video now. You can refer to that because you don't have the reference. One moment. The tutorial just now you saw, right? I post in the chat box. I mean the posting, class posting. You can see there. Where is it going? It takes time, I think. You jam. It's coming out. I'm posting the video. You can refer through. For this one, it is important that you people are going back and referring. I'm planning for online, like streaming or live stream on YouTube, so that you can go back and check what I taught in case of doubt. Somebody may have doubt at second screen or third screen, and they can still go and refer it. I'm planning for. Just give me some time. Now I clash with another duty. I cannot spend a lot of time in this. I'm so sorry. I'm planning for live stream so that you can go back and check. If you have doubt, we will do it soon. 1 minute is still loading. Okay, I've lost it. I've lost it already. You check in your posting, class posting, the video of the calculation we did just now. Raymond is very sad. What happened? How are you,
Yes,
Raymond?
miss.
How are you? You should
I'm
be
good.
smiling face, and all of you should be smiling face. Release
Yeah.
stress. Stress,
No,
do stress analysis module. Don't get stressed too much. Very simple, just logically follow the thing. Muntasir only Rambut, Rambut scene. Just lift up your camera, please. Okay, Muntasir, this gentleman Ongzan, very good. That is our Sadaf Sahir, Kankanala, Kwasar. Miss you. I'm taking camera photo today. I'm planning to take all 13 people in the class. Today 13 are there. No, Adel is missing today. No, Ahmad is missing. Ahmad Nabil. Sadaf is there? Can you switch on your camera? I never get response from you. I'm so sorry. Are you there? Any problem? Sadaf Sahib? Please switch on.
Yes, I'm here. I'm
Good.
here.
Oh, thanks a lot. I was worried. I can hear, but I cannot see you. Please switch on your camera, Sadaf. And Ongzan is here. Novel is not here. Kosar, Kankanala, Ahmad Walid. Sadaf, switch on your camera. Kankanala, are you there? Say hi. Anytime, any problem, you also can give the feedback, Padlet. Unless you say I don't know what is happening and what is your requirement. Have you taken on the question? I moved to the solution, the last one, I put it there for you. Have you taken on the question, all of you? Okay, I show the solution. Last solution, you can follow the same way. Write down the given data. Move on. I think similar to this question. This question. Similar to this question. Yeah, similar to this one. Start from here. Write the given data. Find out the J, find out the J max if you want. No, it's not J max, J only, right? J and J max here is the same. Only thing you need to find. Okay, move to the question itself because a bit different question. You will get sure question in test like this, so practice please. You can ask me doubt now. Have you done? Just two-line problem. Have you all done? Just two-line only if I show the answer. What is the first answer? How much is the, you're asked to find the shear stress at A, isn't it? The question is saying, yeah, shear stress at A and B. Very simple, it's a direct question. How much is shear stress at A? Ahmad Hassan, shear stress at A.
Yes, miss. Just
how
a
much
minute. I will, just a minute. I will answer it, and I will tell you. Just a minute. Okay.
How much? Nava, are you ready with the answer?
No, miss.
Oh, no one is girl. Oh, so sorry. Please switch on your camera. See how much we are missing you. Please switch on your camera. Nawal, Kosar, I know. Sadaf Sagit. Please switch on your camera. You don't have camera, you can put in the chat box, otherwise I don't disturb. Today only, today only admitted. But for exam and all, you need to keep it. I don't know whether it's online exam or on site. Not possible on site. Be true to Yula, no harm. Can you switch on your camera, all of you? Only 5 people here. Anybody got the answer? Okay, I focus the answer. The answer is 9.43. Anybody is getting? Very simple. Shear stress at A is for 9.43. And then shear stress at B. Anybody have the answer? 14.1. Just one line answer only. Let me go through the solution for you. It's in the PowerPoint. Okay. Because the time of I'm given 10 minutes. Just 2 lines question only. Where is this? This one. Just 2 line only. Understanding is required than getting an answer. Let me put in one slide so that easy for me to explain. So it's just a one line answer. All of you listen to this PowerPoint. All of you can see the slide. Just 2 line answer only. I can't get the pin. Can you see the slide?
Yes.
Yes.
Oh, I put on this something else.
Teacher, can you upload the answers later?
Yes, yes. One moment, it's opening my. Okay, done already. You are here in the practice 2, right? Oh, practice 2. Practice. This one. Right. You can see the slide, right?
No.
Cannot. One moment. Yeah, get into the PowerPoint correctly. Okay, yeah. Okay. This is the thing. Just two-line solution. Oh God, thank God I got it. See, you're given with this shaft, right? Fix at C. You have to mind this fixing. Fix at C. Distributed moment of 2 kilonewton meter over meter. Another one like the last time. Additional point moment is also given, and the shaft is defined by A, B, C. A little bit longer here, with another moment at 400 Newton meter acting at the end. All right. The diameter is given. Okay. Diameter. How much is the diameter? 60 meter diameter. Okay. Just two line only. Tau A is TA. They are using C, but ours is rho. Rho over J. Let me correct it. Otherwise, you will have the textbook. They will have different notation, but you make it very the common. I mean, you use the same one. Ours is rho, isn't it? Okay. I should not take this class. This is rho actually. You see the diagrams given there, nicely represented on the way of analyzing this. This is actually rho, okay, and this is also our rho. Okay, when you substitute the rho,
Miss, we can use it C or rho.
yeah, you can use
We
the
must
C is
select
representing the rho distance from the center, because in this text they use rho. It's a worked out example there. Okay, see here at this point, all is all one by one, right? You're asked to find the stress analysis at A and the distribution at A and B, right? For this, you need the torque. What are the moments acting on it, so that you can conveniently substitute here to solve it. How much is the torque here? You plot from here and starting from here. If no torque moment is given, forces are given, you have to resolve and get the moments, isn't it? Torque is nothing but the moment in Newton meter for the given loading. In this case, torque is directly given, alright? In other words, the pattern also given, or the distributor or point also given. So we can directly substitute. Start from here, it is, you multiply 2 times 0.4, how much is the distance? Until 0.8, right? 2 times 0.8, how much is it? 1.6, alright? 1.6 kilonewton meter for the whole, or at the center it is acting right over here. At the center it is acting big one, which direction? In this direction, right? In this direction the value of 1.6 is acting. 1.6, but write the units later, I will correct it. Kilonewton meter is acting. I don't know how to, maybe I use the hand. Kilonewton meter, okay, badly. So you have this value kilonewton meter. One moment, sir. This is kilonewton meter. Keep it with you at the center, okay? Because distributor you change to point. And then moving on, is there any other moment acting? This moment, right? 600. How much is value? 600. Hey, how much is this? 1.6 or 8? Correct only, right? Correct. Okay, moving on, you have this is clockwise, right? When you put the clock here, this one is clockwise, and this one is 600 is acting anti-clockwise. So you will have subtraction, right? You need to, when you subtract, how much is the remaining value? How much is the remaining value? 1000, isn't it? 1000. Then moving on, you come over here until this point is how much? Or you see this diagram. You see this diagram. For this value, only 400 here acting in this clockwise direction. Up to A, there is no other moment, isn't it? Up to A, there is no other moment. So it is still 400. Until it crosses 600, it is still with 400. So conveniently, we can substitute 400 and solve for tau A or shear stress A. But coming to B, it encounters all other types of moments, right? If no moments here, it's still living with 400 only. This point will living with or subjected to 400 Newton meter. Because of this additional two moments, you have to do an analysis like this. Start from here 400, 400, 400 until it reaches the point 600. There is another 600. Moving on, right? This now we resolve into 1.6. Let it be 1.6 for this region. I mark here if you want. Should be getting it quickly. And so I put the which direction? Also in this direction, right? I put the one that is acting represented by a 1.6 at this point, okay? 1.6. Total one we calculated already. 1.6 Newton meter. And then further moving on, there is nothing. It should get vanished at C. That is the principle, okay? It should get vanished at C because we already calculated moment based on the principle that all moments are getting vanished at zero as support, saying that whatever the moment acting, opposite to that will be the support will resist the moment that is acting on the body. That is how the body is in rotation. If it is in rotation, it will be in rotation. If there is any difference, it will start failing, right? That's a principle of design of these material, these elements. Okay, coming here where we are, name. I'll take this one. When you solve for B, okay, you follow this diagram. Okay, follow this diagram. You will have 600 at this point at B, exactly at B. If you resolve also, you will get exactly 600. Right, 1.6 negative, how much is this? Positive, negative, right? Negative. Cut 600 will be 1000. Cut 400 will be 600 at this point. So substitute 600 for B point and then multiply by y.03 also at the wall for the whole member, right? So the diameter is the distance is 0.03. Row value is 0.03 until the surface ends over the same polar momentum inertia substituted to get the answer for shear stress at B. Is this clear? Any question you can ask me? And then the plotting, the plotting you can do it like this. The twisted position also given here. Tau A will be little bit because of the n is clearly away from the point, resisting point. So it will be like this. And this one a little bit twisted at this point due to many moments acting. So you will have a kind of a deformed shape and value is 14. That's why because more deformation than this, so value is very high. You can also observe from the diagram. Any question here? Okay, I stop here for this calculation. I want to show some building testing of building or torsions in buildings. If you have no question. Any question? Are you hearing me?
No questions.
Okay. You have to understand when follow similar questions so that you are familiarized with this type of calculations. I want to show this video. Although it is not in your syllabus about the buildings, it's better you understand some concepts underlying this torsion in buildings so that it can adapt it in your designs later on. Some understanding about the building, you can spend some time on this. Often I didn't switch on the voice. Okay. Please listen to this video, selected one.
Academy, and in this video I'll be talking about torsion in a building. All right, so let us assume that we got a building over here. All right, okay, so this is the top view of the building, or you can see the plan of the building, right? And so let us assume that this building is acted upon by the lateral load. Okay, so it can be from any direction. All right, due to these lateral loads, let us assume that this part of the building, so this part of the building deflects more as compared to this part of the building. Okay, so let us just assume it. And so in that case, what happens is that this building undergoes a rotation. All right, so this rotation we call is a rotation of the building, we call as the torsion. Okay, so simply the torsion in a building is the rotation of the building due to unequal displacement of the parts of the building. All right, okay, so there are different cases in which this torsion can happen in a building. So the case one is, let's say the first case when a building can undergo torsion. All right, so let's assume that so we got a building and the building is in irregular shape. All right, so irregular shaped building. Okay, so in this case what happens is that, so if it is acted upon by the lateral load, okay, so this portion undergoes displacement more differently as compared to this portion. All right, so due to this reason, this area over here is stressed region. All right, and case 2. Okay, so suppose that we got a regular building like this, right? So this is the elevation of the building. Okay, and so this is two portion, and let us assume that one half of the building has higher mass as compared to the other half. Maybe, you know, in this half it may be a library or any storage house, or, you know, in a machine room, you know, and in the other halves, in the other half of the building, let's assume that it's just a bedroom. All right, and so in this case, what happens is that due to this unsymmetry in the mass of the building, so whenever there is the, okay, so this is the plan, right? So there is the lateral load acting on this building. So this portion goes more displacement as compared to this portion, and due to this reason also it undergoes torsion, right? So case 3. Okay, so all right, okay, so case 3 may be that, okay, so suppose so this is the another elevation of the building. Okay, so this is your building, and so these are, okay, all right, so you got infill wall over here, infill wall over here, infill wall over here, but you don't have any wall in this portion, right? So you got only columns from here to here. So this portion also, so when this building is acted upon by the lateral load, this column undergoes more deflection as compared to these columns, right? So due to this reason also, this building undergoes torsion. Okay, so here we talked about the regular buildings, right? So so here we see that if we have a regular building or a symmetrical building, then we can overcome this torsion. Okay, so but let's assume that we got a regular building, right? But what happens is that if we got a staircase at one edge, or you might have shear walls over here and no shear wall here, right? So staircase void here but no staircase void in on the other side, right? And shear wall here as well, right? So in this situation also it looks very symmetrical, right? It's a very regular building, but this is called as the false symmetry. False symmetry. And it is again, you know, this building also suffers from the torsion. So it is best practice to, you know, add these staircase at the middle portion of the building, you know, to maintain the regularity of this building. Okay, regularity in the shape. So how do we know that this building might fail in torsion? So significant torsion will be taken as the condition where the distance between the story center of rigidity, all right, so center of rigidity we denote by K, and the center of mass we denote by M. So suppose M, right? So if the distance, so suppose that we got center of rigidity of the building over here and center of mass of the here, and we know the distance from here to here, suppose it's D, right? Right, and we know the distance from here up to here, so this is the width of the building. Let us assume that it's W. All right, so if D is greater than 20% of W, in this case we have to redesign this building. All right, so redesign the building. So this building will fail in torsion in such situation. All right. So you have to check center of distance from center of rigidity and the center of mass. All right. If this torsion is not considered while designing the building, then there might be severe damages that are seen in a building. All right. So you must always consider the torsion in a building while designing it. All right. So all right, guys. So this was for this video. Hope this video was helpful.
Okay. We understand what is happening. It's only for your understanding and not for assessment in this case, because it's not covered in the syllabus for now. Later I may have to include it. We saw just now that distribution of the loading, right? Distribution of the loading should be uniform. Wherever there is a differential loading or asymmetric loading, you need to plan accordingly to redesign it. That is given by two different points. One is point of rigidity and point of center of gravity, or otherwise called as center of mass. Okay. Here it is all about the center of mass, right? No forces involved, so we use the term center of mass. It's all due to the shape of the material, isn't it? So the difference between the center of mass and center of rigidity gives you the value of the failure. Accordingly you can design it. Actual calculation and formula will involve when you go for design of RCC numbers. Here we don't cover the design. That's why the detailed design. That's why I don't have any examples of this, just for understanding purpose only. There is another one I have to run, quick one, for your understanding of torsions, and so that with that we can you practice more questions related to that. I found this one is very interesting. That's why I want to share with you for more understanding on this topic. Okay, all of you listen to this video. With that we can end our class.
This is structures explained, and in this video we will be talking about torsion as a force and how it acts. In daily life we experience many.
Can you hear? Can you all hear?
Yes, teacher.
Okay.
Instances where we apply torsion to the objects. Opening a door lock is one such moment in which we rotate the key along its main axis to open the lock. The force, also called as torque, is the main player in this scenario. Next, we look at wrenching of clothes to remove water from them. The force at both the ends is applied in opposite direction to twist the cloth, resulting in draining of water. These examples show torsion in action in daily life. Structural elements in a building or a bridge also undergo this force all the time. Let's consider a rectangular concrete beam fixed at one end and applied with a moment or torque along the main axis of the beam at other end. The fixed end will resist the rotation, but the free end will rotate, creating stresses in the cross-section of the beam. From this illustration, we can say that torsion is a vertical movement acting on the main axis of the beam, creating shear stresses in it. Torsion is expressed in either Pascal, an SI unit for newtons per square meter, or in pounds per square inch, while torque is expressed in Newton meters or foot-pound force. When the beam is revolved around its axis, there will be friction between adjacent sections along the beam, and the sections will try to resist the rotation. This will produce stresses in the cross-section of the beam, which will be radially increasing from center to the periphery of the section. Highest stress will be on the outermost portion of the beam and least in the center. This stress will cause concrete beam to produce cracks in it, which will occur at an angle. This stress will cause concrete beam.
Herein you are seeing the stress distribution diagram, right? It's a cross section. Okay, here you are seeing imagine it is a square or rectangular section. It is a cut section they are showing at the center. Okay, a section or the center, a section is taken at the center is 0, increasing to the wall. Center 0, increasing to the surface of the wall is maximum, like that. It's a section, cut section of the member, and the plot of stress distribution across the cross section.
To produce cracks in it, which will occur at an angle of 45 degrees from the cross-section of the beam. To resist these stresses, a combination of vertical and longitudinal reinforcement will be required to arrest the cracks. The longitudinal reinforcement in top and bottom, shown here in blue, run along the beam, and the vertical reinforcement, also called as stirrups, shown in red, are distributed in whole beam. For beams in torsion, stirrups must be closed and having an angle of 135-degree hooks. Sidebars are also provided for resisting torsion if needed by design, which are shown here in orange. The combined action of this reinforcement and internal resistance of the concrete counter the torsion forces and cracks produced in the beam. Now let us see various scenarios in a concrete frame structure where beams are subject to torsion. The model here represents a 3-storied reinforced concrete frame structure with normal slab, beam, column, and footing arrangement. Let's see the building members in various colors for better understanding. So in this 3D view, we can see orange-colored isolated footings, gray-colored columns, red-colored beams, and green-colored slabs. First come the perimeter beams of a building which run all around the building. These beams are loaded only from one side and hence are subject to torsional forces. The beams which are curved in plan are also acted by torsional forces. Then comes beams which are near openings or cutouts in the slab. These beams are also loaded from one side and hence attract the torsional forces. Third kind of beams which get torsion forces are the primary beams which support secondary beams resting on them. These beams are main contenders to get the torsional reinforcement due to the loading from one side. Needless to say, these beams require thorough analysis for their design to resist various forces acting on them. Torsional forces will also be applicable in the whole building when acted by an earthquake. When the center of rigidity and center of mass of the building does not match with each other, eccentric forces will develop, twisting the whole building. That's it for this video, guys. Hope you learned something from it.
Okay, can you answer my question? In reinforced concrete, I don't know whether you studied last time or not. Which portion is taking the torsion load? Here. I don't know, switch on this. Which portion is taking this is important when you go for RCC design also, the same thing you will do. You have to know which is taking which type of force, which is taking tension, which is taking compression, which is taking shear or otherwise rotational moment. Okay, answer me, which one is taking the shear force and the corresponding torsional rotation? Which element here? From the, he just now dictated me, presented here, right? Which component of this cross section? You can also follow this one, or this one, anyone. Both has the answer. Can you answer me? With that, we end our class. Which element is taking the shear load? Nobody knows. Are you there? You left already. Oh, you're there, right? Can you hear me?
Yes.
Yes.
Which portion is taking the load? I'll go back to the video. Stirrups, right? This portion, see? If you want, I rerun this portion only. This is called stirrups. This is called. Okay, all of you have to imagine this as perpendicular to the slide. Here, this stirrup, which is putting all the reinforcement in place, these stirrups, and these sometimes they include in if it is heavy shear loading, then they will also add these orange color bars to take up the shear load. In general, later on you will study when a beam is subjected to loading, top member will undergo compression, bottom will undergo tension force. To counteract, they will provide bars at the top and bottom. At the same time, if it is undergoing a shear, I mean this type of stirrups are always there for all types of reinforcement to take up the shear or any lateral loading that is coming over the building. Okay, remember the stirrups and then any additional power put which are provided at the mid of the section will take up the shear load and the corresponding torsional moment. That is what explained here. I stop here. Any question you can ask me either by message or now you can check with me. What about the exam? Test. You want? I'm planning to give some objective type and some descriptive, like a descriptive in the sense calculations. Is that okay? Are you ready to do the calculation? Unless you practice, I'm sorry, you cannot manage with the calculation. I can conduct only with objectives, but there is no kind of outcome tested already. That's why it involves both objective type and calculations. Are you ready or you want any revision? Next Friday, isn't it? All should get good marks. That is our aim. If any problem, difficulty, if you want, I post all the tutor. Okay, we'll let it be like this to make you understand and familiarize with this. I post all the tutorials, about 50 questions here, about 40 questions minimum, or like 5 tutorials we have solved so far. Each one has 4 or 5 questions, about 25 to 30 questions. I think more than that. I'm sure 40 questions should be there. Practice these 40 questions at least. Read the theory, memorize, keep in your mind which is what is what, and formula, and then practice those 40 questions. I will test you on those 40 similar types of questions. Is that okay? I will not extend my domain because you have left with a few days only. So I limit your study by giving limited portions for which you have to really thorough of. That is how I can help you, not more than that. Okay, practice all the tutorial questions posted so far. If you want, I will give some solutions only, not all the solutions provided by me, and it's become a spoon feed again. Like 40 questions, 20 questions I would have solved already. The solutions are there. You can practice. The rest you practice yourself. The question test paper will be based on these types. Is that okay?
Okay.
Okay, miss.
Okay. Start practicing it. Huh? Already I posted 5 types of tutorials questions for you. Okay, I stop here. Thanks for attending class. Keep learning.
Thank you, miss.